All right. We are on 5.3, sum and difference formulas. And before we actually get to our sum and difference formulas, I want to look at a couple common myths. So the first is that if I take a binomial, u plus v, and I square it, I get u squared plus v squared. Hopefully you're looking at that and thinking, no, that is illegal math. That is a false statement. Why? Well, of course, we have to FOIL that thing, right? So 2 plus 3 squared is really, I mean, we wouldn't use it like this, but I guess we could actually compare this to 2 squared plus 3 squared. And this is a fairly easy thing to see that it's not equal, right? Because 2 plus 3 is 5. 5 squared is 25. 2 squared is 4. 3 squared is 9. 9 plus 4 is 13, I think. And 25 is obviously not equal to 13. We know that if we want to do this, we need to FOIL. The second one is the square root of u plus v is equal to the square root of u plus the square root of v. And similarly, hopefully you're looking at this and thinking, oh, no, that doesn't work. That is also false. So a fun counterexample we could use for this would be, let's say the square root of 16 plus 25. Is that equal to the square root of 16 plus the square root of 25? We can check really quick because the square root of 16 is 4, the square root of 25 is 5. 5 plus 4 is 9. That's on this right side. And then 16 plus 25 is 25, 35, 41, I think. I'm doing this without my calculator. So square root of 41, well, that's not a perfect square, and it's not equal to 9. So we're like, yeah, that doesn't work. If we look at our third, though, the square root of u times v is equal to the square root of u times the square root of v. This guy is true. This is a property of our radicals that if I had the square root of 2 times 100, that is equal to the square root of 200, which is also equal to the square root of 2 times the square root of 100. To show that that's true, I could type all those into my calculator and show you that they're all the same. I'm not going to do that in this moment. But then we've got two other ones. And these are less common myths, I guess, ones that you might not be as familiar with. This third one says cosine of u plus v is equal to cosine of u plus cosine of v. Well, let's consider an example. So let's see if this is true. Let's go with cosine of 30 degrees plus 60 degrees. And the question is that equal to cosine of 90 degrees, right? Because 30 plus 60 is 90. All right, so I'm considering my unit circle. I need these 2 points and the point 0, 1. This is 30 degrees. This is my 60 degrees. And 30 degrees is square root of 3 over 2, 1/2. And 60 degrees is 1/2, square root of 3 over 2. All right, that was a really quick unit circle. So cosine of 90 degrees, right up here, sine is y, cosine is x, is 0. Cosine of 90 is 0. And then let's compare that to cosine of 30 degrees plus cosine of 60 degrees. Cosine of 30 degrees is square root of 3 over 2. Cosine of 60 degrees is 1/2. I can add these fractions because they have a common denominator, but I see that it's equal to the square root of 3 plus 1 all over 2, and that is not the same as 0. So this statement up here is not true. It is, false. Which leads us to the properties on our next slide. And I'm not actually going to look at the next example right now because it's not totally necessary. So we just saw that cosine of 30 plus 60 is not the same as cosine of 30 plus cosine of 60. And we need to then look at some sum and difference formulas. I'm going to ask you, well, so here's the catch. In a normal school year, I would hand out all of these formulas in a print-off, and I might be doing that. I have to make sure I actually print those, but every single formula you see in this section will be given to you on a test or a quiz. You don't have to memorize these formulas, but you do need to know how to use them. So our sum and difference formula, we will start with sine, and we are given the following statement. Sine of alpha plus or minus beta is equal to sine of alpha times sine of beta, or excuse me, times cosine of beta plus or minus cosine of alpha times sine of beta. Don't stress out. These symbols are angles, right? And this plus or minus that we see is not saying I'm deciding whether I add or subtract. It's saying if I am finding, let's say, sine of angle x plus angle y, that'll be equal to sine of x times cosine of y plus cosine of x times sine of y. So if I am adding the angles originally, I'm going to add them in this formula. They're basically writing two equations at once in this statement. Cosine is very similar. Cosine of alpha plus or minus beta is equal to cosine of alpha times cosine of beta minus or plus sine of alpha times sine of beta. So notice here, they are flipping this sign. So if I'm trying to find, let's say, cosine of 10 degrees plus 30 degrees, I would be then subtracting those in between later. When I'm adding originally, I am going to subtract in the formula, and when I'm subtracting originally, I'm going to add in the formula. That's what that plus or minus flipped over looks like. And then the last one would be, of course, tangent. Tangent of alpha plus or minus beta is equal to tangent of alpha plus or minus tangent of beta all over 1 minus or plus tangent of alpha times tangent of beta. So notice again, they are not saying we are doing both adding or subtracting, but this is basically writing two formulas in one. As I mentioned just like 35 seconds ago, or maybe like 3 minutes ago, you will be given all of these formulas here on a test or a quiz. I'm not expecting you to memorize them, but I do need you to understand how to use them. So we're going to do this example right now in this video, and then we'll practice a little bit more in class together. It says, find the exact value of sine of 75 degrees. Now you might be thinking, and rightfully so, 75 degrees is not an angle on our unit circle. So how can I find sine of 75 degrees? Well, I can use these sum and difference formulas to help me out. Hopefully you're looking at 75 degrees and thinking, well, I could write 75 as 30 degrees plus 45 degrees, and both of those angles are on my unit circle. So I'm going to take a moment. I'm going to take a moment, and again, I'm just going to sketch the first quadrant. I know I need 45 degrees, which is square root of 2 over 2, square root of 2 over 2, and 30 degrees, which I know to be square root of 3 over 2, 1/2. And now I can use my sum and difference equations to help me out here. So if I go back up for a moment, sine of alpha plus beta is equal to sine of alpha times cosine of beta plus, because notice these are the same direction, plus cosine of alpha times sine of beta. So I'm really just using the formula, plugging in the values. Oops. And now I use my unit circle. Sine of 30 degrees, sine is y, is equal to 1/2. Cosine of 45 degrees, cosine is x, is the square root of 2 over 2. Cosine of 30 is the square root of 3 over 2, and sine of 45, square root of 2 over 2. I can multiply these fractions to get square root of 2 over 4, right? When we multiply fractions, we multiply numerator, multiply the denominator. I can also multiply these fractions, and remember, because of our rule from before, square root of 3 times the square root of 2 is the square root of 6, all over 4. And because we have a common denominator, I can add these fractions, square root of 2 plus square root of 6, all over 4. Now I cannot add 2 and 6. Remember that was our, we looked at that earlier, but this is my final answer. It's not like a beautiful number, but that's okay. It is still a number, and it is kind of lovely, maybe. Another thought I had while I was doing this is maybe you looked at 75 degrees and you thought, oh, I could write sine of 75 degrees as sine of 120 minus 45. Wait, that might not actually be right. Hold on. Nope, that's right. Sorry, I was second guessing my math skills. And this is also totally correct. Like I could write 120 minus 45, that is 75, and I could use those angles on my unit circle, and I would get to the same place here. So you can add or subtract values to get to 75 degrees as long as they are angles on our unit circle, and you'll still get the same answer. We will continue these notes in class, and I will see you soon. Have a good day.